we have taken a really good look at systems of equations and solving for them, let's now set up a couple, based off a word problem. So let's go ahead and read this word problem. This is a real popular type of word problem. I'll talk about the strategy as to how to deal with them, and then we'll solve for it. So taking a look at this problem is we have a canoe that can travel 12 miles downstream in the same time they can travel 5 miles upstream. If the speed of the current is 5 miles per hour, what is the speed of the canoe in miles per hour? Now I know this is a long problem. I know there's a lot of stuff going on. But let me talk about my strategy first. The first thing I want to recognize is what is equal. Something's going to be equal. Either the distance is going to be equal or the time is going to be equal. And one thing you need to know is distance is equal to your rate times time. Now in this case what it told me is that in the same time, it can go 12 miles downstream in the same time that it can travel 4 miles upstream. So whether you're going up or down, the time is the same. The time is the same either way. You need to identify what is equal. Sometimes the distance might be equal. Sometimes the time might be equal. So just be aware of that. In this case, the time is equal. Now let's talk about my distance. Your distance, you went 12 miles downstream, and then you went 4 miles upstream. And so going upstream, you went 4 miles. Going downstream, you went 12 miles. Finally, dealing with your rate. The speed of the current is 5 miles per hour, but you are looking for the speed of the canoe. Whatever you're solving for, that's going to be my x. I'm going to label x. My variable x is what I'm looking for. And in this case, it's the speed of the canoe. Your x, no matter what, is always going to be what are you looking for. Okay? Sometimes you're going to be looking for the speed of the current. Sometimes you're going to be looking for a lot of things. But in this case, your x is going to be what you're looking for, the speed of the canoe. But how do I deal with my rate? Well, the speed of the current is 5 miles per hour. If you're going upstream, you are fighting the current. So you're doing the speed of the boat, that x, but then current's pushing you back at 5 miles per hour. So your rate is the speed of the canoe minus 5. Okay? Your x, the speed of the canoe, minus 5 going upstream. But guess what? Going downstream, man, you're going your speed, plus it's now pushing you forward. And so because of that, your rate, your speed is going to be faster. It's going to be x plus 5. So what I'm going to do, now that I have this set up, I'm going to set this equal to d equals rt. Now my t is the same. Let's keep this in my up and down, right? My t is the same. So my t up is equal to my distance over my rate going upstream. My distance going upstream is 4. My rate going upstream is x minus 5. Now the time going downstream, and the reason I'm solving for time right now is because that is what's equal to each other. The time going downstream, which is distance divided by rate, we divide the rate over, this is going to be 12 over x plus 5. And because the time going upstream is equal to the time going downstream, we're going to set these two equations equal to each other and then just do algebra to solve for x. So going upstream, we would have 4 over x minus 5 is equal to the time going downstream, 12 over x plus 5, and now we just do algebra. Let's multiply the x plus 5 to each side, and we're going to multiply x minus 5 to each side. So what I'm going to have is 4 times x plus 5 is equal to 12 times x minus 5. So multiplying the 4 into here, we're going to have 4x plus 20 is equal to, multiplying the 12 into there, 12x minus 60, and now we simply do algebra to solve for x. So what I'm going to do is let's subtract the 12x to the other side, so minus 12x, minus 12x, and then move this 20 over to the other side, minus 20, minus 20. What I get, 4 minus 12x is negative 8x, minus 60 minus 20, that's minus 80. Therefore, solving for x by dividing -8, I get that x is going 10 miles per hour. Go ahead, join us in the next video. I'm going to give you another word problem that we're going to set up, another really popular type that I want to go over that you may see on exams.